This next section is about functions. So you'll have seen in GCSE function notation, you'll have started with function machines that look like this and eventually moved on to proper function notation, where the function is called f or g or some other letter. This is your input of x, and this is what the function is doing to the x. So some straightforward examples. Given f of x is 4x plus 2 and g of x equals x squared minus 2, find these substitutions. F of 7 just means substitute 7 into f. So 4 times 7 is 28 plus 2 equals 30. G of minus 4, substituting minus 4 into there, gives minus 4 squared, which is 16. Take away 2, giving us 14. And then a combination of the two, f of 10 divided by g of 3. F of 10, 4 tens are 40, add 2, 42. G of 3, 3 squared is 9, take off 2 is 7. 42 divided by 7 gives us 6. Working in reverse, given that f of something is minus 18, work out what this something was. So we know that 4a minus 2 is equal to minus 18. So 4a's must be negative 16. So a is negative 4. And finally solve g of x equals 0. G of x equals 0. Add the 2 and square root. X is plus or minus root 2. Find the roots of f of x, given that it's a cubic, x cubed minus 2x squared minus 24x. Or we can start here by factorising an x out. This then factorises again quite nicely. Giving us our 3 roots. X equals 0. X equals 6. And x equals negative 4. Some more examples. Again, 2 functions, f and g. This, if you've not met this before, this symbol, they are formed using two lines. We often write it like that. Those are the real numbers, which are basically all the numbers you're used to dealing with. All integers, fractions, decimals, square roots. A, find f of minus 4. Substituting minus 4 into there. Minus 4 squared. 3 lots of minus 4 with the negative. Gives us 28. Part B. When is f of x equal to g of x? Well, here we can just equate the two functions. X squared minus 3x equals x plus 5. Take it all to one side to give us a quadratic. Factorise that. And we have our two solutions. X equals 5, x equals negative 1. At C, find the roots of f of x. Roots meaning when is it equal to 0? When is f of x equal to 0? Well, we can factorise that. Giving us 2 roots. X equals 0, x equals 3. Same for part D. The roots of g of x. When is this equal to 0? When is g of x equal to 0? When x is minus 5. Final one, determine the minimum of this function and state the value of x for which it occurs. Well, if you recall from the sketching section, to find the minimum of a quadratic, we complete the square. So we'll complete the square on this. Half the 6, square it, 3 squared is 9, we'd have to subtract 7, which gives us our minimum value. The minimum for this function occurs when x equals 3, so this becomes 0, and we get minus 7. So our minimum value is minus 7. And it occurs when x equals 3. That's it for function examples. If you have a go at these questions from the exercise in the textbook, and move on when you're ready onto the next section, which is what we call disguised quadratics. So we know a quadratic is anything of this form, ax squared plus bx plus c. But the quadratics can be disguised so that it's not immediately obvious what the value that's being squared is. This is a normal one, a quadratic in x. The x is squared, it's an x here. This one's a quadratic in y. We've got a y squared and a y here. This one, however, is a quadratic in x squared, because the thing being squared is an x squared. X squared squared gives us x power 4. The next term has the x squared in it. And we have a plus 10. So we have something squared minus 8 times something plus 10. So it's a quadratic. So can you spot what these are quadratics in terms of? Pause the video, have a go, before we have a look at them. So you should see that this one is a quadratic in y squared. This one is a quadratic in z cubed. Z cubed squared is z to the power 6. It's a z cubed here. This one, harder to spot. It's a quadratic in w to the power of half. When you square w to the power of half, you get w. No, it's just w to the power of half. This next one is a quadratic in 2 to the power of x. This is 2 to the power of x squared, and this is just 2 to the power of x. Similar here. This is a quadratic in 3 to the power of x. When you square that, you get 3 to the power of 2x. And this last one is a quadratic in 1 over z. If you square this, you get 1 over z squared. And this is 5 lots of 1 over z. So you may need to solve disguised quadratics. You can use a substitution, but sometimes it's easier just to go for it. So what I mean by using a substitution, we can see that this is a quadratic in y squared. So you may say, right, let's let y squared equal x, and then rewrite this as a quadratic in x. Solve that, put the y squared back in, and then work out what y has to be. Or you can just leave it as it is. Maybe rewrite it as a quadratic, as you'd expect to see. And then go ahead and solve this in whatever way you need to, hopefully by factorising. This one does factorise. So our brackets now have to have y squared in them, not y, because it's a quadratic in y squared. That's it factorised. From these brackets then, equaling 0, here we get that y squared has to be 4, and here we get that y squared has to be 9. So our values for y, we have to go an extra step and square root them. Plus or minus 2, plus or minus 3. This one's similar. It's a quadratic in w squared. Once again, it factorizes quite nicely into w squared minus 9 and w squared plus 2. So this one gives us that w squared has to equal 9, and this one, w squared has to equal negative 2. So here by square rooting, we get plus and minus 3. Here we can't square root, because we can't square root a negative. This one is a quadratic in x to the power of a half, so we could rewrite it. X power of a half squared plus an x power of a half. This one again factorizes nicely. Plus 3 and a minus 2. So w to the power of a half has to be minus 3 for this one. X to the power of a half is positive 2 for that one. So to get back to what x is, we would have to square them. Squaring this gives us x, so squaring this gives us our solution of 9, and squaring this gives us our solution of 4. Next one is a quadratic in z cubed. We have z cubed squared, 7 lots of z cubed. Factorizing nicely again. Negative 8 plus 1. Z cubed equals 8. Z cubed is negative 1. So we have to go the extra step of cube rooting. The cube root of 8 is just 2, and the cube root of minus 1 is minus 1. This next one we can see is a quadratic in 3 to the power of x. 3 to the power of x squared minus 10 lots of 3 to the power of x plus 9. Factorizes to give 3 to the power of x minus 9. 3 to the power of x minus 1. 3 to the power of x equals 9 and 3 to the power of x equals 1. So now we're saying, what power would you stick on a 3 to give you 9, and what power would you put on a 3 to give you 1? Well, you would have to square 3 to get you a 9, and a power of 0 will produce the 1. This one's similar. 2 to the power of x is a term being squared. Factorize it. Give me minus 4 and minus 8 in the brackets. To the power of x has to be 4 or 8. And again, we're asking what power would you put on a 2 to give you 4? Well, you'd square it. And what power would you put on a 2 to give you 8? You would cube it. Okay, next one's slightly different. You might think, right, we just have to subtract this 5 to make it equal to 0 so that we can solve it. But then, what's this a quadratic in? What's being squared here? It's not z to the minus 1, because if we square z to the minus 1, you get z to the minus 2. Well, if we just rewrote this, to turn this into a quadratic now, we can just multiply everything by z. We multiply everything by z, get z squared plus 6 equals 5z. Subtracting the 5z. Gives us our quadratic that we can solve. This now is a more straightforward one. So a little bit harder to spot what's going on there. Similar to the next one. Have a look at that. 2 to the power of x. This isn't just 2 to the power of x squared, because that will be 2 to the power of 2x. We've got this extra plus 1. So what's going on here? Well, this extra plus 1 must be coming from multiplying by 2 again. If you multiply by 2, you add an extra 1 to the power. So this is actually 2 lots of 2 to the power of 2x. Which, if you want to, you can write it as 2 to the power of x squared. Then it's in the more familiar quadratic form. So when we factorise it in one bracket, we're going to have 2 lots of 2 to the power of 2x. I could write that as 2 to the power of x plus 1. I'll leave it as it is. And in the other bracket, we're just going to have a single 2 to the power of x. And then just figure out what has to go into the brackets. It would have to be a minus 1 and a minus 4 to give us our coefficients there. So from this one, we've got 2 lots of 2 to the power of x must equal 1. And here, 2 to the power of x equals 4. So you will have to divide by 2. And say, what power would you put on a 2 to give you a half? That would have to be a negative 1 to turn it into the reciprocal. And what power would you put on a 2 to give you a 4? Well, you would square it.